Okay, so again, we want to do the shaded area, in case we've already forgotten, divided by the total area. What shape is the shaded area in this problem? How many? 4 circles. So the shaded area is 4 circles, correct? What is the shape of the total area in this problem?
Square.
The total area of the dartboard in this problem is simply a square. Now we need to find the areas, but notice how we don't have any numbers. That's weird. How are we going to find the areas without numbers? You get to choose your own numbers.
Oh,
Woohoo! Choose numbers.
1.
Okay. You know what? The easiest number to use is probably 1. However, you can use anything you want and you'll still get the right answer. So, Alejandra, tell me what number you want me to use for the radius of these circles. They're all the same size. We'll just choose a number for the radius and use it for all of the circles.
4.
You want to do 4? Okay, that's fine. That means we'll have to reduce it a little more at the end, but it'll be a little more exciting than just using the number 1. But 1 is usually the easiest, just saying that, okay? So we're going to say that each circle has a radius of 4. Let me blow this up just a little bit. Okay, so if each circle is going to have a radius of 4, that means we want to find the area of each circle where the radius is 4. Now, does the radius have to be 4, or could it be anything you want it to be? Any number you want it to be. So let's find the area if the radius equals 4. So we go pi times 4 squared. So that would be what? 16 pi, right? So that is 1 circle. How many, you don't have to write down every teeny tiny little detail I'm writing down because I realize you're not going to have time or room. We actually are not going to do the problem here at the bottom. We're going to skip that one. So if you want to fill in this space down here, you could. Okay? All right. So that's 1 circle. So how many circles are there?
4.
The 4 circles means we're going to have to do 4 times 16 pi. Because each circle is 16 pi, so the 4 circles would be 4 times 16 times pi. Right? Okay, now, since we chose a radius of 4, how big is the square? So across that way is 4, and across to there is 4, and across that circle is another 4, and across the rest of that circle is another 4. So it will be a total of 16 on each side of our square, correct? So the square at the bottom will be 16 times 16 because it's a square. It's the area of the square, right? Okay, now all we need to do is find numbers for these two things and then divide them. So you need a calculator now. 4 times 16 times pi. Everybody do that. 201.06. Okay, now do 16 times 16. Well, it's the area of a circle is 16 pi, and then there's 4 circles, so we're multiplying it all together, right? So 16 times 16 is 256. Okay, so there's our ratio. I don't think we can reduce that because it's already a decimal over a fraction. Okay, but if we don't reduce it, we still probably want a percentage. So let's go ahead and find the percentage by taking 201.061928, whatever it is, divided by 16 squared, which is 256. 78.5%. You know what? That's the same exact answer that my second period got today, and they used a radius of 5. I've also done this problem before with a radius of 1 and gotten the same exact answer. How come you can get the same exact answer with different radiuses? It's all ratios. It's probability. It's ratios. Okay? So it doesn't matter what length you use, you're still going to get the same answer as everybody else. Okay? So let's just quickly look together at the problems on your assignment today. Just specifically, I wanted to look at these two here because they're the tricky ones. So remember how on the one we just did, I wrote this out for us, and I said this is 4 circles divided by the area of 1 square, right? So that was the one we just did. But now this one is kind of weird because we have a half a circle, a half a circle, a half a circle, a half a circle with a square in the middle. So what's the shape of the stuff that's shaded? The stuff that's shaded is just 2 circles, right? Put those together, you get 1 circle. Put those together, you get another circle. Okay, and then what's the total area? This is weird because the total area includes the square and the circles because it's a weird shape, right? Yeah. So look, the total area would be the area of the 2 circles plus the area of the square. So what you're going to do is assign your own number for the radius. Like assign your own number for the radius, and I would use 1 because 1 just means smaller numbers to work with. It doesn't really matter. But if the radius of your circles is 1, then how big is your square going to be? The square will be 2 by 2, which is an area of 4, right? So you don't have to use those numbers. You can use your own numbers. But any numbers you use, as long as you take the area of the 2 circles and divide by the area of the 2 circles plus the square on the bottom, and you have to add that before you divide, you'll get the right number, the right answer. Okay? This one's a little strange because it's a square dartboard, but instead of the area we want to hit being a circle, the area that we want to hit is from taking a circle away. Right? See how the circle has been whited out? And it's the area in between. So the top of your ratio is going to be the square minus that circle, right? So you take the area of the square, whatever number you assign to it, and you subtract out the area of that circle. Then you divide it by the total area. What's the shape of the total area? It's a square. So you just assign it your own numbers and find the area of the square and the area of the circle, and then you go square minus circle divided by square. You can use whatever numbers you want, but you do want to assign it some radius so that the side of your square is double the radius, right? So you could use 2 if you want to keep the numbers small, or you could use 10 if you don't care, right? It doesn't matter. You're still going to get the same answer. Do you get the idea of what you're doing? Not at all? I want to give you some time to work, but I drew up a little picture of some of the other problems you're going to be doing. Let me just kind of back this out, and then I'll leave this up here while you're working. Problem number 5 involves time, so you want to use a segment. Problem number 10 involves time, so you want to use a segment. Problem number 6 involves area of a baseball hitting a dunking machine, you know, that makes someone fall in the water, like you would have at a carnival or something. And how it works is there's a disc in the middle of this meter, like this big square that you're trying to hit that as your target. And so if the baseball even just barely nicks the side of it, it will make it sink. So even though the disc in the middle is 8 centimeters radius, because the ball is an additional 3.6 centimeters, you actually add your radiuses together. So the total radius you'll use is 11.6 centimeters because the ball can hit anywhere in there and it'll still set it off. The other problem is it tells you that the backboard is a meter, but you do this part in centimeters. So what do you need to do with the backboard part of it? In meters or centimeters? You need to do it in centimeters or your answer is not going to work out. So you need to change 1 meter to 100 centimeters for your outside square. Okay? So I will just leave this picture up there so as you're working you can look at it. You're down to only like 12 or 13 minutes to work, but seriously, there's only 10 problems. You might honestly be able to get this done in class today and not have homework over the break, okay? If you get it done today and turned in today, you'll get a bonus point. So please work hard for me. Any questions? You guys have been good. I can tell you're sleepy, but you've been really, really good. Yeah, Logan? Yes.